Hey guys, real quick, we're looking at growth and decay. This is like a 5 minute little spiel. That's about it, so we can get you guys started. So, growth and decay. So, we've already talked about growth problems. So, we got here, let's just call this y equals 2 to the x. And so then it's over 1 and up 2 for 1 and 2. And then we have some that looks like this, right? So we've got those problems that look like that. That's a growth problem. So this one grows. So it grows higher and higher and higher. This is where you want your money to go. Now we call what's a decay problem, where instead of it pointing up and to the right, it actually comes down to the left. Okay? So those are a little different, and they look a little different because what we're doing at that point is we're changing the base to less than 1. So in other words, the idea is that the base is a fraction smaller than 1. So the base is less than 1. Okay? That's the main idea. Or the exponent is negative. So like for this particular one, we still have, let's do y equals 1/2 to the x. This is still an exponential function, but it's a decay function because 1 and 0, 0 and 1 is my first main point, but then the 1 and the base becomes 1 and 1/2, and so the point's down here lower than that, and so it curves down and gets closer this way. Okay? So that's the idea behind decay problems, is this has to be less than 1. It could be a decimal, a fraction, whatever it is. The other thing is this. If I just took y equals 2 to the negative x, what we're really saying is, and I'll move it off to the side here, we have 0 and 1 and 2. That's our original one if there was no negative, but this negative tells us to make all x's negative, which, oops, there it is, which moves it over here, and then it's an easy idea of it's a decay problem. So whenever the exponent's negative or the base is less than 1, they're decay problems. So when the base is negative, or when the exponent, couldn't fit it in there, guys. The exponent has a negative coefficient, like this one here. So like what we just talked about. So that one is when the base is, that's not negative. What am I talking about? Sorry, guys, erase that. My brain. When the base is less than 1. So the fraction is less than 1. So let's look at all of these. So 1.2. This base is greater than, this is a growth. 2, but my exponent is, this is a decay. Exponent's negative, this is a decay. 7 over 8, that's going to be smaller than 1. This is a decay. This is a decay. Whoops. We have a negative in front, doesn't really matter. We got this one here. This is a growth. Okay. This one's less than 1. This is a decay. 17 over 15, that is actually bigger than 1, so this is a growth problem. This is a decay because this is smaller than 1, so that's a decay. This is how they'll ask you things like this. Is it a growth or a decay model? This one is negative in the exponent, so this is a decay. This is a decay. That's a negative. That's a decay also. This one is still a growth. That one's a tricky one. That one's still a growth. This one's still a growth. This one is a decay. So that's literally what you're looking for, is a base less than 1 or a negative exponent. So then there's your practice problems from there. So that is today's little mini lecture.